Okay, sorry about that. We ran out of time, I ran out of video right at the end. So what I was doing right at the end was I did on the calculator inverse sine of 0.5 and I got 30 degrees. And what I was about to say was if it hadn't worked out to be perfect, if it had a whole bunch of decimals, please keep 2 decimals. I know in math they tell you to round to the nearest degree. In physics we don't. Okay, so on the sheet that you're gonna would have worked on last night, what I had said in class was keep 2 decimals. So I'm just saying it again in case you didn't hear me in class. Okay, so I asked you to find 2 things. I asked you to find the angle, we just did, and I asked you to find the adjacent side. Okay, so to find the adjacent side, we have a bunch of different options. We could use Pythagorean Theorem, right? Because a squared plus b squared equals c squared. Or now that we have the angle, and I know it's perfect, it's 30 degrees, I haven't rounded it, I could use cosine or tan. So let's use cosine just to make sure you know how to use your calculator, because I know you can do a squared plus b squared equals c squared. So if I did cosine, it's the adjacent over the hypotenuse. So adjacent over 10 meters. And I want to solve for the adjacent, so I would multiply both sides by 10. So to be 10 meters times the cos of 30. The cos of 30 is 0.866 times 10. This is going to be 8.66 meters. Okay, now a second ago I said you could have also used Pythagorean Theorem, a squared plus b squared equals c squared, but this time you would be looking for one of the sides, not the legs. So it'd be a squared is equal to c squared minus b squared. So 10 meters squared minus 5 meters squared. So a squared would be equal to 100 meters squared minus 25 meters squared. A squared would be equal to 75 meters squared. Take the square root of both sides, and if I was a betting nun, I bet you get 8.66 with a few more decimals there. Look at that, 8.66. Because you should get exactly the same answer, no matter which way you do it. Okay, so I had asked for you to do last night the day's class homework was to do this sheet. So decide which trig ratio you'll use, write it down, find the missing angle. Show me. Show me what, you don't have to show me every step, but show me this. Show me this. Show me what you're using, please, and make sure you put your units in. Okay? For number 2, find the measure indicated. So sometimes it's a side, sometimes it's an angle. So find what they're asking you for there. Number 3, decide on the trig ratio you would use to find h. H is not the hypotenuse, it's the side that's labeled h, okay? And then find it. Again, show me your work. And do this on a separate sheet of paper. It's going to be way too crowded and too messy if you try to fit it all in here. And then number 4, you had to find 2 different things, x and y, x and y, x and y, x and y. Okay, when you come back to class, I will ask if there were any issues, but I am going to ask you to hand these in so I know you can do trig. If you get stuck on the back side, there's a couple more examples. Okay, so that's your trig sheet. Next on the stack of sheets that I gave you to take home are one that talks about precision and significant digits, sig figs or sig digs. Significant figures, put too many I's in there, or significant digits. And I know you would have seen these in math, I think, and maybe grade 10 science. All right, so if you had a number like 745, and I cross my 7s, so you can tell they're not my 1s, how many sig figs would this have? I'll wait for you to answer. I hope you're saying 3. But what if it was 7,450? How about now? It should still have 3 because this 0 doesn't count because there's no decimal there. But what if it was 7,450 written like this? Now how many significant digits does it have? I hope you're saying 5. Because now with the decimal here, both of these zeros count. Okay, so how about if it was 0.0002? How many sig figs? Answer, 1. Just this 2. What if it was 0.000200? I'll put another one on. How many sig figs here? 4. Everything from the 2 over. So the rule usually is you go to the non-zero number that's furthest to the left-hand side. So here it's 7, 7, 7. And you count to the right. And you don't count the zeros on the end unless there's a decimal there. So in these two, you go to the number that's non-zero number that's furthest to the left, and it's the 2. And you count to the right. Well, there's only the 2. There's nothing to the right. Here, though, you still start at the 2, but this time there are other things to the right, so those 3 zeros count. Now, what if I were to put a 3 in front of that 0 up there, and it was 0.002000? How many sig figs does this have? Well, if we use our rule, go to the non-zero number furthest to the left and count to the right, and if there's a decimal there, then these zeros count. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. This dude has 9 significant digits. Okay, and what if I had, let's say, 4,000? How many sig figs? The answer is 1, because the 3 zeros don't count. But what if I wanted to write 4,000 with 2 significant digits? How could I do that? I can't put a decimal there, because if I put a decimal there, then it has 4. But if I only want 2, because remember, significant digits really are telling us how confident we are in our measurement, right? If I'm using a meter stick to measure the width of a hair, then I'm not going to be really confident in my decimal places. But if I'm using my meter stick to measure the length of a desk, I would have more confidence in my decimal places, and more digits would be significant. So in a measurement of the width of a hair with a meter stick, I'd probably only have 1 decimal place. Okay, so here I want to write 4,000 with 2 sig figs. What do? I use something that's called scientific notation, which I think you've heard of. And I could write this in scientific notation. It would become 4 times 10 to the, and the decimal is implied to be here, so I move it, times 10 to the 3. And if I want 2 sig figs, then I write it as 4.0. This now has 2 significant digits. We'll come back and talk about that more probably in the next video. Okay, so if you look at your sheet, I gave you a sheet with rules. Okay, non-zero numbers are always significant. Leading zeros are not significant. Any zeros between 2 significant digits are, so the 0 here counts. Okay, a final 0 or a trailing 0 in the decimal portion only are significant. So these guys count, this counts, this counts, this counts. But if it was like that 4,000 without a decimal, they wouldn't count. Okay, so now we will need to talk about adding and subtracting. So what's the rule for adding and subtracting, multiplying and dividing? So for adding and subtracting, you look at it's kind of a weird wording, so we'll read it and then I'll translate it. When adding or subtracting measured quantities, the calculated answer should be rounded to the same degree of precision as that is the least precise number. So if you look here, we have 12.3, we have 0.12, and we have 12.34. So the first step is to add them up and get an overall answer. And then you say, well, which one's least precise? The one that's least precise is the one that has the least number of decimals after, which is the 12.3. And it only has 1 decimal place after, which means my answer can only have 1 decimal place. So this can't be 25.76. I'm only allowed to have 1 decimal place. Since this 6 is greater than a 5, I round up, and my answer becomes 24.8. Does that make sense? Okay, stay tuned to the next video for multiplying and dividing.